Hello dear students, once again welcome back to our channel. In this video we are going to start the problems based on Pythagoras theorem and its converse. In the previous video I have given a very detailed explanation of the proof of Pythagoras theorem and its converse, and the results also we have discussed, so please do watch that video. Okay, let us start the first problem of exercise 6.5. Here we have 4 sub questions under question number 1. And each questions we have given the sides of a triangle. 3 sides of a triangle are given. And first thing is we have to check whether this will form a right triangle or not. If so, write down its hypotenuse. That is the question. Okay, how can we check a triangle is right triangle or not? At least one of the angle must be 90 degree. Okay, but here the answer, the question is in terms of sides. Then how can we get that one of the angle is 90 degree? Then only a triangle will become a right triangle, isn't it? Okay, so we have the converse of Pythagoras theorem. What is the converse of Pythagoras theorem, children? Okay, if in a triangle the square of sum of the squares of 2 sides is equal to the third side. Okay, so that angle opposite to that third side will be 90 degree. That is the converse of Pythagoras theorem, isn't it? Okay, so we can move to that first sub question, that is 7 centimeter, 24 centimeter and 25 centimeter. We are expecting that is the longest side is the hypotenuse. Understood? That means in among this 25, if this will form a right triangle, definitely 25 is the hypotenuse because the longest side is the hypotenuse. Okay, and the other two sides are 7 and 24. If 25 square, okay, is equal to the sum of the squares of other two sides, that is 7 square plus 24 square. That means this will be the sides of a right triangle, and hence you can say that 25 is the hypotenuse. That is the procedure what we are going to follow these 4 problems. Okay, so let us see. We can write down first 25 square. We know that is 625. Children, please learn the square numbers up to 30, at least 1 to 30 the square numbers we should know. And what is 7 square is 49 and 24 square is 576. Okay, this is the units. Okay, that means if we can show that the 7 square plus 24 square equal to 49 plus 576. If you add 49 and 576, you can see that this will form 625. See children, 576 plus 49. 15, 1 carries 11, 12, 1 carries 625. Okay, and 25 square is also 625. It is clear? So can we write this in the form 25 square equal to 7 square plus 24 square, which implies this 7 centimeter, 24 centimeter and this 25 centimeter are the sides of a right triangle. Okay, you will get a right triangle under these measurements. Okay, and hence you can select 25. In this case, the longest side. See children, this sum of the squares of other two sides. Okay, this third side is the sum of the squares of two sides. Okay, see if you mark like this, see children, A, B, C, this will be 25 and this is 7 and this will be 24. Okay, so the side, the angle opposite to this longest side, that means angle B will be 90 degree. Okay, so 25 is the hypotenuse. Okay, this is the way we can complete all the problems of this question. Okay, in the second question, 3, 8 and 6. 3, 8 and 6 means we can take the square, and we know that 8 is the longest side among these 3. Okay, so we can start with 8. 8 square equal to 64. 3 square equal to 9. 6 square equal to 36. See, if you take this 3 square plus 6 square, that is 9 plus 36, that is 45. Okay, that is not the that is the sum of 3 square and 6 square is not the square of 8 square. That means these three sides, if we have these three sides, we cannot construct a right triangle. Okay, so that means here 8 square, being 8 square is not equal to 3 square plus 6 square, implies the given sides are not the sides of right triangle. If so, how can we write down the hypotenuse? Okay, only the right triangle having the hypotenuse. Okay, that means the a side opposite to 90 degree. Okay, so this is not possible. And what about the third question? Here we have 50, 80, 100. Okay, so we are taking first 100 square. Okay, 1, then 2 0, so 4 0. Okay, into 100, that is 10,000. Okay, and 50 square. What is 50 square? How can we square 50 square? That 5 5s are 25. Okay, see children, 50 into 50, right? 5 5s are 25. See how many 0 here? 1 0, so 2 0. Okay, that is 2,500. And 80 square. The same way, 80 into 80. Okay, that means 8 8s are 64. Okay, 64 and 00. Okay, now we are going to check whether this 50 square plus 80 square will give you the square of 100. Okay, that means here we have 2,500 plus 6,400. Okay, see what is there, sum children? That is 8,900. In this case also, that means this sum, the square of 50 square plus 80 square is not equal to 100 square. That means these are the given sides will not form a right triangle. In that case, we can write the hypotenuse. Understood children? Now we have a fourth question. That means in the fourth question we have given 13 centimeter, 12 centimeter and 5 centimeter. Okay, we can take 13. First, so this is fourth question. Okay, 13 square. What is the square of 13? 169. 169. Okay, and 12 square is 144 and 5 square is 25. Okay, we are going to take the sum of the squares of 12 square plus 5 square. Okay, that is 12 square plus 5 square equal to 144 plus 25. 169, right? 144 plus 25. Okay, 5 4s are 9. Okay, 6 plus 4 plus 2, 6 and 1. Okay, that is 169. And this is equal to square of 13 square. So the last problem also, that given sides will form a right triangle. Okay, since 13 square, we have seen that 13 square is also 169 and 12 square plus 5 square also 169 implies the given three sides will form the sides of a right triangle, and hence the longest side will be the hypotenuse, and in this case that will be 13 centimeter. This is all about the first question. Now the second question, triangle PQR is a right angled at P, and M is a point on QR such that PM perpendicular to MR. Show that PM square is equal to QM into MR. Okay, so first of all we can draw the triangle based on the given details. We have a right triangle PQR, right angled at P means angle P is 90 degree. Right angled at P, no doubt you have to mark this angle as P. Right angled at Q means here you have to mark Q. That is the difference. Okay, since here right angled at P, we have PQR and M is a point on QR such that QM perpendicular to MR, which means this angle being it is perpendicular. See children, this is QR, okay, and from the point P, this PM. Okay, that means this angle is 90 degrees. So that means here these two angles, okay, of both the triangles is 90 degree. Okay, and we have to prove that PM square. So first of all children, you identify, Okay, that side, this question is in terms of sides of the triangle. Okay, PM square means this PM square, this is a side. QM, this side. Okay, this is QM, and that second one, that is MR. MR is this one. Okay, that means this question is okay based on the sides of this triangle, and PM is common between these two triangles. Okay, and we have a very important result to get this answer. That means if a perpendicular is drawn sorry, from the right angle of a right triangle. Okay, what is the result? The triangles on both sides of the perpendicular is similar to the whole triangle, big triangle PQR. Okay, this triangle is similar to PQR, and this side, the triangle on this side of the perpendicular is also similar to this whole triangle. And one more result, and similar to each other. That is, this triangle is similar to this triangle. Okay, that is the result we are going to apply in order to get the required result. Okay, but in particular here we need in terms of these two triangles. Okay, why? Because here QM and MR, this QM, these are the sides of this big triangle PQR. Okay, these are the sides of one triangle PMQ and RMP. Okay, so that means we have to consider this relation, that is similarity of this triangle with this similarity. Okay, so we can start, children. That means since PM perpendicular to QR, because of that result. Okay, this triangle is similar to whole triangle, and this triangle is also similar to the whole triangle. So the whole triangle is common. So I am going to keep that triangle LHS. Okay, so triangle PQR is similar to, okay, the triangles on this side of the perpendicular. Okay, so in order to get its correct symbolic form, you just see that the position of the angle. Here in triangle PQR, angle P is 90 degree. That is given. So, which angle is 90 degree in this triangle? That is angle M. So, here since P comes in the first position, here M should come in the first position. And in both the triangle PQR and triangle MPR, angle R is common. Whole triangle and triangle on this side of the perpendicular. Okay. So, here R comes in the third position. So, here R comes. So, the remaining vertex, that is P, that is triangle MPR, similar to triangle PQR. Okay, this can be equation number 1. And also triangle PQR is also similar to the triangle of this side of the perpendicular. Okay, here also we have to write in correct symbolic form. Okay, so here in triangle PQR, P is 90 degree, and here angle M of this triangle is 90 degree, and Q is common. Okay, so Q should come in the second position. M is the first position. Angle P and angle M are 90 degrees. And the angle, the remaining one is P. That is MQP. This is the triangle, and this is the correct symbolic form. Okay, triangle PQR is similar to triangle MQP. Let it be equation number 2. Okay, that means you can equate these two. Okay, so triangle MPR is similar to triangle MQP because of these. And in particular, we need this relation. I already informed. Here we need QM-MR. Okay, and QM and MR are the sides of these two triangles on either side of the perpendicular. So I am going to take this third relation. Okay, and next I am going to write this in terms of ratios are similar, because here we don't want in terms of angles. Here the answer is in terms of sides. Okay, so I am considering that point, that is MP by MQ. If they are similar, you can write their corresponding sides are in the similar ratio. Okay, that is PR divided by QR, which is equal to MR divided by here MP, right? Okay, MP. Okay, so MR divided by PM or MP, doesn't matter. Okay, and from these three, which can be taken, okay, in order to get that answer, see here we need PM square. So PM, MP is PM, that we know, MQ, here PR by QR. If you are taking this ratio and this ratio, we can reach into that answer. So in the third ratio, MR and PM, we need MR also PM. Okay, QM, so that means I am going to take this ratio with the first ratio. I am going to equate first and third. MP by MQ, we need MQ and also MR and PM square. See, so this can be cross multiplied in order to get the required form. So MP into PM, that is PM square. MP is PM, so PM into PM is PM square. PM square equal to MR into MQ. Okay, that is MQ into MR. Okay, so then see that answer. PM square equal to MQ into MR. We know that MQ and QM are the same. So QM into MR, and this is PM square. This is the required result. Now the third question. Here ABD is a right angled triangle, right angled at A, and AC perpendicular to BD. Show that we have three sub questions in this third question. Okay, we can solve one by one. So the first sub question, AB square equal to BC into BD. Okay, so what is given, children? Triangle ABD is right angled at A. So that means you have to mark here A. That means here is angle 90 degree. Right angled at A and triangle ABD. So here comes B and here it is D. And what is the next thing? AC perpendicular to AD. Here also a perpendicular is drawn from the vertex of a right angle of a right triangle from A. This is right angle of this right triangle ABD. So this perpendicular is AC, which means this angle and this angle is 90 degree perpendicular. Okay, show that AB square equal to BC into BD. So because of that result, if a perpendicular is drawn from the vertex of a right angle of a right triangle, the triangles on both sides of the perpendicular is similar to the whole triangle and similar to each other. This is the result we can apply in order to get these three results. Let us see, we can check one by one. Okay, so here which is the result we can take? Here AB square equal to AB means this whole side. The side of this big triangle, also this is AB is a common side of this triangle on this side of the perpendicular. Okay, and we should get that answer in terms of AB square, and another one in RHS BC. BC is the side of this triangle in this side of the perpendicular. Okay, and BD. BD means the whole side. BD comes in triangle ABD. So which relation we have to take? That is triangle ABC is similar to this triangle. This small triangle, right triangle. Also we have this triangle ABC similar to this triangle on that side of the perpendicular. And finally these two triangles also similar. Okay, so in order to get into this answer, I am going to consider this whole triangle. Why? Because we need answer in terms of BD, and BD is one of the side of the big triangle ABD. Okay, and since BC is here, so you have to take that relation. That means we know that triangle, since here AC perpendicular to BD, then only we can apply these all results. Okay, and also A is 90 degree. So since AC perpendicular to BD, okay, so you can write this whole triangle ABD is similar to this triangle. Whole triangle is similar to this triangle, and these two triangles on either side of the perpendicular is also similar to each other. Okay, and in order to get this, I am taking this triangle along with the whole triangle. Okay, that means triangle ABD, okay, is similar to triangle. When you are writing the second part, this should be in correct symbolic form. That angle should place in correct position. In triangle ABD, which is 90 degree, okay, ABD, this angle A is 90 degree. Okay, and hence in this triangle which is 90 degree, angle C is 90 degree. So C should come in the first position. In triangle ABD and a triangle BCA, okay, angle B is common, right? This triangle and the whole triangle. So B here, since it is in second position, here this B also should come in the second position, and the remaining vertex is A. So CBA. Okay, and in order to get this result, I already told we need this side BD. That is why we selected this one. Okay, so from this, let it be equation number 1. Okay, I am considering the ratio AB by CB equal to BD by BA, and that is equal to the third ratio, okay, AD by CA. And in order to get this result, AB square, this one, AB by CB, BD by BA is AB. So AB and AB get squared. So AB square is equal to BD into CB is BC. So I am taking this first and second ratio. So which means AB square, see children, AB square equal to BD into BC. Hence the first result. Okay, BD into BC or BC into BD, both are the same. See children, in order to get the second one, AC square equal to BC into DC. AC square, see children, what is AC here? AC is the side of this triangle, that is both the triangle AC is common, so we can't say that which is the needed one. So let us look into the RHS part. BC. BC means again this one, the side of the second triangle, okay, and DC, that means this one. That means in this relation we don't have any side from the longest, that whole triangle. So that means we have to take these two ratios. That is, triangles on both sides of the perpendicular is similar to each other. Okay, is it clear children? So we have already equation number 1. Okay, that means this triangle is similar to the whole triangle, and next, in order to equate these two triangles are similar, first we can write this is similar to this one. For that we have, this is a second question, second sub question. So triangle ABC is also similar to triangle. See, in triangle, this triangle, right triangle, here A is 90 degree in ABD, here which is 90, C is 90 degree, here ABD, isn't it? Okay, that means angle C and D is common angle. Okay, so D should come in the third position. So A here comes. So CAD, verify whether it is in correct symbolic form, otherwise you can't reach into the required answer children. So children, A here, B is not B, D is common, so third position. Here angle A is 90 degree, here angle C is 90 degree. Okay, so A should come in the first position, here C should come in the first position. So our symbolic form is correct. So we have the second one. See, the first and second one, ABD similar to CBA. Here ABD similar to CAD, which means you can equate its RHS part. Okay, that means from 1 and 2 you can write, or these triangles on both sides of the perpendicular, CBA similar to triangle CAD. Okay, which means, okay, you will get BC or CB divided by CA equal to BA by AD equal to AC, the third ratio, AC by, here third ratio, CD. And in order to get AC square, children, see children, CB, CA, here AC. So we have to equate first and the third one, that is from this, okay, that is CB by CA. Here CA into CA, that is AC square equal to BC in terms of that BC is CB is BC into CD. Okay, CD is DC. Just change, that doesn't matter. So this is the second result, that is AC square is equal to here BC into DC. See now the third result, that is AD square equal to BD into CD. So let us verify which are the sides given. So AD is a common side, it's a big side, side of the big triangle as well as this triangle is on that side. Okay, and BD is the longest side from the big triangle, and CD, see children, this is the CD, the side CD. So we have to consider the big triangle along with the triangles of that side of the perpendicular. Okay, and we know that they are similar to each other. So this is the third question. Answer, that is triangle ABD. I am fixing this triangle ABD similar to, in that this triangle here A is being 90 degree, and in this triangle this C should come in first position. So triangle C, and in both triangle D is common, triangle ABD as well as triangle this triangle. Okay, that is CDA, D is common, so D should come in the third position. So A in the middle. So triangle CAD is similar. Okay, because AC is similar, AC is perpendicular to BD. So triangles on both sides of the perpendicular is similar to the whole triangle as well as similar to each other. That is the result, that is the main result we are applying in order to get all these three results. Okay. Now we can equate their ratios. The first ratio AB and AC equal to second ratio BD and AD, and third ratio AD and CD, AD by CD. See, we need AD square. So here is AD, here also AD. So if you are taking second and third, you can easily get that answer, required result. So I am going to cross multiply second and third. So AD square equal to BD into the CD, CD is there. So this is the required result. AD square equal to BD into CD. Now the fourth question, this is very simple question. Okay, triangle ABC is an isosceles right angled triangle, right angled at C. We have to show that AB square equal to 2AC square. So we have a right angled isosceles triangle. Isosceles triangle means the two sides are equal, and here one angle is 90 degrees. Isosceles right triangle. So we have here a right angled isosceles triangle. Right angled at C means here comes C, the vertex C. Okay, and here A and B. So A, B, C is an isosceles right triangle at C. Since it is isosceles, okay, two sides are equal, and since it is 90 degree right angled triangle, so hypotenuse is the longest side. This cannot be equated to this AB is a hypotenuse, that is the side opposite to 90 degree. So this side cannot be equated to either BC or with AC. That is the longest side. So the only choice goes to this BC equal to AC. Being it is isosceles, two sides must be same, and that cannot be equated to its hypotenuse, because hypotenuse is always the longest side. So we can, from the question you can write, given triangle ABC is an isosceles right triangle at C implies AC equal to BC. See children, since it is right triangle, you can definitely apply Pythagoras theorem. Pythagoras theorem is only for the right triangle. Okay, so by Pythagoras theorem, in order to get into this answer, by Pythagoras theorem, okay, we have square of the hypotenuse. Here the hypotenuse is the longest side. the side opposite to 90 degree, is equal to sum of the squares of other two sides, AC square and other side BC square. See, since it is isosceles, we have this result AC equal to BC. Okay, and we need answer in terms of AB square and 2AC square. Okay, that means we don't want BC. So we can substitute for BC. We need in terms of AB as well as AC. Okay, I am going to substitute for BC square as AC square since AC equal to BC. Okay, that is the next step. So AB square equal to AC square plus again AC, BC equal to AC, so AC square. Here the reason is given AC equal to BC. So in place of BC, AC. So square, so AC square. So children, AB square equal to AC square plus AC square. So you can add AC square plus AC square will give you 2AC square. So this is AB square in the LHS. So this is the required result. AB square is equal to 2AC square. Now the fifth question. Here triangle ABC is an isosceles triangle with the AC equal to BC. If AB square equal to 2AC square, show that triangle ABC is a right triangle. That is the question. See children, how can we show that a triangle is right triangle? In terms of its sides, the question we have given in terms of sides, AB equal to AB square equal to 2AC square and also AC is equal to BC. Nothing is given in terms of angle. Okay, so how can we show that this will form a right triangle under this given condition? Okay, see children, this is the only method. Okay, that is you can apply the converse of Pythagoras theorem. What is the statement of the converse, children? What it says? That is, if the square of one side of a triangle is equal to sum of the squares of other two sides. Okay, that means one angle will be 90 degree. The angle opposite to the first side will be 90 degree. That is the converse of Pythagoras theorem. If we can show that that result is holding for this problem, you can say that means this will be a right triangle. Okay, for that we are going to apply this given two details, that is AC equal to BC and AB square is equal to 2AC square. So first I am going to consider this given, that is AB square is equal to 2AC square. So I am going to split this AC square plus AC square. Okay, this 2AC square into AC square plus AC square. So you will get 2AC square. So from 1, AB square can be written as AC square plus AC square. When you add, you will get 2AC square. Okay, so see the second one, AC equal to BC. Okay, in this case we cannot apply this converse of Pythagoras theorem because AC square plus AC square, sum of the squares of one side itself. Okay, so if you can show that this is equal to, the AB square equal to sum of the squares of other two sides. Okay, so for that children, what is given? AC equal to BC is given. So I am going to substitute for one of the AC in terms of BC. What is the problem? It is given that AC, the length of AC and length of BC are the same. Okay, so which means AB square equal to, I am keeping this AC square without any change, and for this AC, okay, because this is BC, so BC square, AC square equal to BC square. So from this what we have got? We got that the sum of the squares of these two sides is equal to AB square. Okay, that means the angle opposite to this AB square will be 90 degree. That is angle C equal to 90 degree. From this, which implies angle C equal to 90 degree. Why? Because of converse of Pythagoras theorem. Okay, if in a triangle the sum of squares of two sides is equal to the square of the third side, so the angle opposite to this third side will be 90 degree. Okay, here the angle opposite to AB is angle C. So angle C is equal to 90 degree means triangle ABC is a right triangle. That is a required proof. triangle ABC is a right triangle, just because of converse of Pythagoras theorem. Okay,